All right. This will be our 5th class for grade 12 math. This will be our last class for the statistics unit and also the last class for this week. And I'm only going to we'll start the new unit next week, but just one class later in the week, maybe Thursday or Wednesday at the earliest. I'll probably put it up like Thursday morning. You'll be getting a third hand-in assignment for this unit coming up today. So you'll be busy enough getting those 3 hand-in assignments finished off and handed in. So this will be the last recording for this week, and there will be only one recording next week for our final unit, which will be precision measurement. So that's the housekeeping business. Let's get on with the remainder of this unit. The concept of percentiles. What is a percentile? You will find this begins on page 67. Lesson 5, percentiles, page 67. And they provide a nice example that shows nicely what a percentile is. Suppose you got 88% on an exam. Your first impression might be that you did extremely well on that exam. 88 is pretty good. However, once you start talking to other people in the class, you realize that most of the students have a higher mark than you. Receiving a high mark on an exam shows that you knew most of the material that was tested. However, this high mark does not tell you how you did in relation to other people who wrote that exam. Percentiles are used to compare one score with the rest of the scores. So maybe this was a very easy exam and you should have been able to get like a 98 or a 99 on it, but you got an 88. So an 88 might be a good mark on a very tough exam, but maybe this was an easier subject. Or maybe you're just taking a course with a whole bunch of very smart people, whatever the case might be. But the point of percentiles is to compare one piece of data to other pieces of data. Exam marks are just one situation where percentiles are used. Percentiles are used in analyzing children's growth, including their height and weight. So when our baby gets weighed and measured, she is compared to other children in her age range using percentiles. What is the percentile? Where is she supposed to be at this age? Physicians will often use the child's height and weight percentiles to compare the child's growth to other children in the same age group. Overall, percentiles are a very useful statistic when you are interested in comparing data values. You're looking at comparing one piece of data to the rest. So, let's write a definition of percentiles, first of all. Percentiles are used to compare one piece of data to the rest of the data. And this is known as the percentile rank. This is known as the percentile rank. That's your basic definition of what a percentile is. Now, let's have a look at page 68 and 69, a couple of examples. So again, percentiles are used to compare one piece of data to the rest of the data. This is known as the percentile mark. The test mark, the weight of a baby, the amount of grain produced by one field compared to all the other fields. Like if you have one field that did 65 with canola, well, that's pretty good average. But what if all your other fields did 75? So it was a really good year for canola. So this, you would think that this one other field should have done better as well. Let's look over here. You received a mark of 88% on an exam. Suppose 100 students have written the same exam and only 10 of these students have scored less than 88. Also, no other students have scored exactly 88 besides you. How does your mark compare with the marks of the other students who have written the exam? Well, 11% of the students are over here less than you, and 89% of the students are over here more than you. So you think you did pretty good, you got an 88, but when you rank it as a percentile, you're all the way over here. So this might be a test on which you maybe should have done better, or maybe there's 89% of the class is just really smart and did very well. But that's a percentile rank. You're comparing it how you did to how everybody else did. Let's look at another example. This one you'll find on page 69, example number 2. Suppose, however, that 100 students who have written the same exam as you, 88 of them score lower than 88. What does it look like now? Now you have a mark of 88 and you're all the way up here in the upper echelon. Only 11% of the class did better than you. So if 100 people wrote the exam, only 11 of them did better than you. Whereas before, only 11 of them did worse than you. So you can see how we can use percentiles to compare. So that mark of 88 on this particular exam is probably much better than a mark of 88 on the other exam where almost everybody got that much anyways. So again, you're comparing it that way, and it gives you a more accurate reflection of how you did. So we'll work our way through a couple of percentile examples, but the first thing we're going to do is copy the percentile rank formula. You will find it on page 70, but we're going to write it down anyways because writing things down is better than just reading them. We know that. And grade 12, you should know that for sure. Percentile rank formula. B, add 1/2 or 0.5 times E, divide by N, that's all in brackets, times 100. Now, what the heck does that mean? B are the number of scores below a given score. E number of scores equal to the given score, including the given score. including the given score. And your N is the total number of scores. So, that's the percentile rank formula. The number of scores below, add 0.5 times the number of scores equal, divide by n. So you can, by the total number of scores. So you can see how the formula is giving you a number that tells you where you rank compared to others. You can see how that would be. You're looking at the scores below, the scores equal to, divided by the total number of scores. You can see how it makes logical sense. Now let's look at example 3 on page 70. Here we have a set of numbers, and we want to find the percentile rank of 40 and 83 from this set of numbers. So we're going to start. Let's first of all look at how many numbers we have altogether. 32. 4 by 8. So we're going to take our formula. We're going to start working with the number 40 first. We're going to find the percentile rank of 40 in this set of numbers. Right? So, in the formula, I need the number of numbers that are below 40. Okay? So, let's find out. They've got them nicely arranged in a column. So that's easy. There's 3 of them that are below 40. 3 plus 0.5. How many are equal to 40? Just 1. How many numbers do we have altogether? Sorry, I should have moved this down. Up. 32 times 100. Let's do this. 3. 0.5 times 1 is not going to change that. Let's stay 0.5. So we have 3.5 divided by 32. .109, almost 0.11. I'm going to round it to 0.11. Times 100 is, of course, equals 11. So we have a percentile rank of 11. So that's a very low percentile rank, which you would expect if you had a mark of 40. That's a pretty poor mark. That's a failing mark. You would expect to have a very low percentile rank. Not always. Could be a test in which everybody got 40s and 50s and maybe a few 60s. Then your or maybe some 30s. Then your percentile rank wouldn't be as bad. But in this case, there seems to be a test where more than half the class passed. So then if you got a 40, well, your percentile rank would be pretty low. So let's look at a percentile rank for 83 now. And we're looking at the numbers that are below 83, and there's a ton of them. There are 24 that are below 83 at 0.5, and there are 3 83s in this data set. Times 100. 0.5 times 3 is 1.5, obviously. So 24 add 1.5 is 25.5. times 100. 5 divided by 32. 0.796. I'm going to round that to 0.80. And if I multiply that by 100, I'm going to get 80. So you're in the 80th percentile. That means you're up here someplace. You're not one of the top. Any percentile over 90 would indicate that you're in the 90th percentile. Now you could be in the 90th percentile with a mark of 45. If it's a test where everybody got that kind of a mark. Doesn't necessarily follow, but generally, if you have a good mark, you're going to be in a very high percentile. I mean, if you look back at the example that we had, a person was in a very low percentile with a mark of 88. That could happen. But again, we're ranking your mark as to where it's at compared to all the other marks. And the person with the 40 is in the 11th percentile. The person with an 83 is in the 80th percentile. And that's the bottom line there. Let's have a look at page 72 and 73. Properties of percentile ranks. Properties of percentile ranks. 72 and 73. Properties of percentile ranks. Now that you know how to calculate a percentile rank, it will be easier for you to understand the properties of percentile ranks. These properties include the following. The percentile rank is a number between 0 and 100. This number indicates the percent of data values equal to or below that specific data value. There is no 0 percentile rank. The lowest score is at the first percentile. So the lowest score you can get is 1. There is no 100 percentile. The highest you can get is a 99. The higher the percentile rank, the better the score compares with the other scores. The lower the percentile rank, the worse the score compares with the other scores. Percentile ranks are written as whole numbers. 32.5 becomes 33, which is the 33rd percentile. You round them off. You don't have decimals. You cannot calculate measures of central tendency based on percentiles, as results may be misleading. Okay, so you don't want to take an average. You don't want to take a whole bunch of percentiles and find out their average. A percentile is a percentile by itself, and you use it as a percentile. You don't find a mean, median, and mode. Let's say you had a percentile ranking for a whole bunch of different exams and you took the average. That doesn't mean anything. That's just work. That's just spending time playing around with the numbers, basically. Once you have a percentile, it stays a percentile, and that's all there is to it. You use it to compare where you're at according to other people and other marks and other weights or whatever it is you're doing. Percentiles and the median. In addition to the properties mentioned above, some percentile values are given special names. These values include the 25th, 50th, and 75th percentiles. The following percent bar displays these percentiles and their special names. Note that the 50th percentile is the middle value, which is the median. This is consistent with what we know about the median. 50% of scores are above the median and 50% are below. So here's your bar. We don't need to write this down, I don't think. 25%, we call that the lower quartile. 50th is the median, and 75th percentile is the upper quartile. So those are three very common percentiles. And of course, you know this from money and from fractions. 25, 50, and 75 quarters of a dollar and so on. So these also have a special place in percentiles. A couple of more things here. Percentiles, P20 is the 20th percentile, P85 is the 85th. So percentiles, if I'm talking about the 31st percentile, P31. Maybe I'm talking about the 99th, P99. Or the whichever. 37th. P37. Okay? So just a couple of things about percentiles here. The quartiles, and then the way percentiles are written as a subscript. Let's have a look at page 73. A survey is conducted in a community of 200 families. The survey yields the following percentiles on family income. So here we have the information. First percentile, 23,500. Median, 32,500. Second percentile, 48,000, or quartile, upper quartile, 48,000. And in the 90th percentile, 100,000. Okay? So, let's answer the questions about this. Page 73, example 4. A. Approximately what percentage of families in the community earn more than 100,000 a year? Well, that's the 90th percentile. So from 90 to 100 is 10. A is 10%. Approximately what percentage of families in the community have a yearly income of 78% or less? Well, that's the 75th percentile if we look at the numbers. So that is simply 75%. And C, approximately how many families in the community have an income of 23,500 or less? Now we're looking for an actual number of families. That's the 25th percentile. It's 23,500. Let's move C down here. That's 25% of the families. We're talking about 2,000 families. So 2,000 times 25%, 0.25. Who can do this in their head? A quarter of 2,000, break 2,000 into 4 parts? 500. families. That's page 73. We're now going to go to page 76 and have a look at our brain power questions. Let's read them through first. Calculate the mortgage. How much money she'll have to pay off on her house. If Carmen bought a house for $210,000 and had a down payment of $32,000. Solve for x. X plus a number plus 5 divided by 6 equals 7. That's the number. 75% of 2,300. What is the sum of the digits from 1 to 10? Marcel is getting ready for school in September. He has bought a binder, pens, pencils. Estimate how much he has spent on school supplies. All right. Brain power, page 76. Bought a house for $210,000. Made a down payment of $32,000, and the question is, how much does he have left to pay off? Well, let's do this mentally. 210 take away 10,000 is 200,000. Take away another 10,000, 190. Take away another 10,000 is 180. That's 30,000. 2,000. I hope you all got 178,000 without using a calculator. X plus 5 divide by 6 equals 7. Think of this like a number divided by 6 equals 7. So what divide by 6 equals 7? Well, 7 times 6 is 42. So how do I get 42 up here? What number do I add 5 to get 42? That would be 37. It's 37 plus 5 then becomes 42 divided by 6. 7. Simple. 75% of 2,300. Can anyone break 2,300 into 4 parts in their head? Anybody that good? 575. And then you do 575 times 3. But anyway, 2,300 times 0.75 is our shortcut. And that becomes 1,725. What is the sum of the digits from 1 to 10? I suppose we can write them out. Couldn't be that difficult now, could it? 3, 6, 10, 15, 21, 28, 36, 45, and 55. Some of the digits from 1 to 10 would be, yes indeed, 55. The school supply guy. They're giving us 3 different numbers. They're asking us to estimate how many school supplies he bought. Well, I'm going to do this. 1146 is going to become 1150. And 626 is going to become 625. And 367 is going to become 375. So 11, 6 is 17, and 3 is 20. This makes a buck, that's 21, and there's 50 cents here. That's $21.50. Simple as that. Anything over 20 bucks would pass for not too bad of an estimate. We're going to look at a couple of percentile examples before we get to talking about the last hand in assignment. Go to page 77. We'll do 1 and 3 on page 77. Carl receives his first mark of the year in his law course. His teacher tells him he scored in the 94th percentile. Should Carl be happy with his mark? So this is page 77 to 78, exercises. Number 1. The answer is, of course, yes. Yes, if you are in the 94th percentile, that means you have one of the highest marks in class. And unless everyone else is not too bright, you should have a high mark. Sure, you could be in the 99th percentile with a 55. But you scored as well or better. You're in the top 6%. You scored the same or better as compared to 94% of the people in that course. If there's 100 people in the course, then 93 of them got a mark that's less than yours. That's pretty good. We're not doing number 2, we're doing number 3. Yes, I was going to do number 3. Number 2. These we'll just work through. I don't need to write them on my loose leaf. We'll work our way through them orally. The higher the percentile rank of a score, the greater the percent of scores above that score. That's false. The higher up you go, the less people will be above you. Okay? If you're way down here, then there's a whole pile better than you. A mark of 75 sometimes has a percentile rank of 75. Oh no, sorry, always has a percentile rank of 75. That's false. You can have a percentile rank of 75 with pretty much any mark. It's about how well you did compared to the rest of the people. Sure, it's possible, but always? No. A mark of 75 never has a percentile rank of 75. Never. Sorry, sometimes, not never. Sometimes comes first. Sometimes, true. It could happen that you have a mark of 75 and your ranking is also 75. It could happen. A mark of 75 never has a percentile rank of 75. False. If this is false and this is true, then this must be false. A percentile rank of 0 is possible. That's false. Percentile starts at 1. It is not possible to have a mark of 80% and a percentile rank of 80. That's false, of course. And a percentile rank of 50. Of course, that's possible. You have a whole bunch of people who had 85s and 90s and 95s, and you had an 80, then your percentile rank's going to be somewhere in the middle. Yabber. The higher the percentile score, the better that score is compared to the other scores. Of course, that's true. That's the whole point of percentiles. A percentile rank of 70 indicates that 75% of the scores are above that score. That's false. 30% are above, not 70. If you had a percentile rank of 30, then 70% of the scores would be above you. P50 is the median. That's true. It's the middle. That's what they call it. 2 equal scores have the same percentile rank. Yes. If those scores are on the same test, then of course they'll be in the same ranking. If you have exactly the same mark on the same test, you'll have the same percentile rank. Of course you would. 2 different marks on 2 different tests. It's another story. We're going to be looking at next on page 78, 5 and 6. We've already done an example like this one, number 4. So we leave that, did that, and look at 5 and 6. A total of 620 individuals take a government employment examination. Lena scores 586 out of 800. That's her percentile rank. There are 498 individuals who score less than 586, and no one has a score of 586. Find her percentile rank. So, page 78, number 3. So, marks that are less, 498, at 0.5, there is no one else that has a 586. It's the only one, so it's times 1. How many people took this test? 620. Times 100. So this simply becomes 498.5. Divide by 620. .4, so 80. 0.80 times 100 equals 80. She is in the 80th percentile. To the mark. And that's A. B. What's the mark that she got on this test? Well, she had 586 out of 800. Yes, 800. 586 divided by 800. 73.25, so 0.73. Multiply that by 100 is 73%. So her mark is 73%, and she is in the 80th percentile. So that's pretty good. That means only 20% of the people have a mark that's higher than hers is. That means that 73 must have been a pretty decent mark on this particular exam. Must have been a harder exam. It must have had a lot of questions out of 800 marks. That's substantial. Okay, we're going to look at page 78. This was supposed to be number 5, not number 3. Page 78, number 6. 78, number 6. And let's have a look. Shira's final mark in her grade 12 essential math class is 92. Out of the 30 students in her class, 3 other students received the same mark and 26 students have lower marks. Find her percentile rank and then find out how many students have a mark higher than hers is. Alrighty. A, percentile rank. Well, how many had a mark that was less than hers? 26. At 0.5, did anyone have a mark that's equal? 3 people, including herself, is 4. Divide by 30 students in the class. Times 100. 0.5 times 4 is 2, so that's 26, add 28. Let's go over here so we don't run out of space. 26 and 28 give you 54. Divide by 30. What am I doing? This is supposed to be 28, not 54. 26 add 2 is 28. So 28 out of 30, for heaven's sake. 0.93, or if you multiply by 100, she is in the 93rd percentile. That's pretty good. 92%, and she's in the 93rd percentile, so only 7% of the class got a higher mark than she did. B, how many students have a final higher mark than Shira? Well, 7% of the students, but we have an interesting situation here. We have a situation where a whole bunch of people got the same. 4 people had a 93, including her. So what percent of the class is 4 students? Let's do 4 divided by 30. That's 13% of the class. Okay? So really, there can't be anyone who got a higher mark. 4 people had a mark of 93. Which is 13% of the class. Thus, no one had a higher mark than Shira. Because that 93rd, she's at the 93rd percentile, and she has a mark of 92. There should be 92, not 93. Then there can't really be anyone higher, because if there were 3 other people, so there's 4 people with a mark of 92, well, there's no room for anybody to be above them then, if they're already at the 93rd percentile. Thus, no one has a higher mark than Shira. Hope that last question is clear to you. If it's not, you can ask a question in the comment box, or you can ask me about it in person if you're not completely sure about it. All right. Take a look at that hand-in assignment. Just hang on. We're almost done here. Just doing a bit of organizing before I get to that final assignment. We'll be doing entire assignment, analyzing percentiles. You'll find it on page 81, begins on page 81. It's worth 20 marks. Your third hand-in assignment for this unit. Your first problem is to find somebody's percentile rank with the information given. They're giving you the students that are lower, the students that are higher. Just use the formula. And then he needs a percentile rank of 70 to be considered for university. Is his percentile rank high enough? It's 1A and B. Number 2, they're giving you 3,000 students were analyzed and the following percentiles calculated. So they had a P20, 48 students were in the 25th percentile, 62 in the 50th, 78 in the 75th, and 89 in the 90th. What percentage of students scored less than or equal to 62? That's here. 50%. So just simply find 50% of 3,000, and that's what you do each time. How many students scored less than or how many students? So here you just write the percent. That's easy. 62%. Here you calculate the actual number of students. Okay? Approximately how many students have scored more than 48? More than 48? That's here. So 25% scored 48, so all the rest are higher, so that would be 70. That would be 75% of them. Okay? So you take the total number of students times 3,000 times 0.75, right? Median mark, well, P50, 62. Todd has a final grade 12 average of 89. The college he wishes to attend will not consider any applicant if his or her percentile rank is below 82. Can Todd be sure the college will consider his application? Can he? He's got a nice average of 89. Is that going to be good enough to get an 80 percentile rank of 82? Probably. As long as there aren't a whole bunch of people in his class getting 90s, he should be able to get a percentile rank of 82 with that kind of mark. It's not 100% sure, but he ought to be pretty safe with that. That's a decent mark. Page 83. You find number 4 and 5. Sonia scores 38. Oops, on a recent test. Her percentile rank on the test was 82. What can you conclude about the success rate of most of the other students who have written the test? Well, they bombed it. 81% of the students had a mark that was less than 38. Woo! What could cause test results like this? It was a hard test. They didn't study enough. Maybe it was an unfair test. I don't know. Maybe it was a really hard unit and then they wrote the test on a Monday. Who knows? That's a really bad test. So there'd have to be a whole lot of things going wrong, unless they've been doing that all year, but I hope not. Georgia is 1.6 meters tall. She is taller than 56 students in her grade. No one is exactly the same height. There are 152 students, so find her percentile. Take the students that are less at 0.5 times 1, because she's the only one, right? Divide by 100, there's a percent. You get a percentile rank. What percentage of students is taller than Georgia? So wherever she ranks, if she's an 82, then 18% of the students are taller than she is. If she's a 72, then it's 28%, right? If she's a 50, then it's half of them, 50%. All depends what you get. Number 6, some true and false questions about percentiles. We did a bunch of examples like that back on whichever page it was on. So you could probably, when you get to this part of the assignment, maybe, and you're not sure, maybe you can review. That would be useful to look at the ones that we did as true and false. Page, I can write down the page quickly. Like that. It's on page 77. Let's take a little note. Example on page 77. Mother takes her child Bryn to the doctor for a checkup. The doctor says Bryn's weight is in the 65th percentile and Bryn's height is in the 45th. How does Bryn's weight compare to children her age? Well, her weight is in the 65th. That means 35% of children are heavier than she is, and 65% are the same weight or lighter. Her height is in the 45th. That means 55% of children are taller than she is, and 45% are either the same height or less. Pretty simple, right? Last question. They're finishing with a nice, easy question. So this is a 20-mark assignment that wraps up the unit on statistics. There's 3 assignments that should be coming in. Let's quickly review what those 3 assignments are, shall we? Let's get shut off the document camera here. Yeah. Let's have a look. Assignment 7.1, mean, median, mode, and outliers. And that one was worth 34 marks. It went from page 29 to page 34. Flipping ahead to the next handed assignment. Five measures of central tendency. Assignment 7.2 was worth 46 marks. It goes from page 61 to 66. That's probably the longest assignment to do. And then the one that we just looked at on percentiles, which is, of course, on page 81. And it goes to page 84, and that one has 20 marks. It's quite short. I don't think it'll take you that long, especially if you do it immediately after watching this lesson and doing the exercises. I would predict you could do that last assignment on percentiles fairly quickly. I think. So, today is Wednesday. There's another math, and I'll be posting this class on Thursday morning because my recording didn't work on yesterday. So we posted on Thursday morning. There's supposed to be a math class on Friday. We'll cancel that class. I won't post a recording on Friday. And I'm not going to post another class until Wednesday or Thursday of next week. So we're going to skip the next 2. We're not going to have any recordings for the next 2 class periods. Get those 3 assignments done, handed in, and you'll need to pick up your package for the next unit. I should have that ready fairly soon, your print package that you're going to need. So you can hand in the statistics stuff for marking and pick up your precision measurement print package. So again, no class until the middle of next week, something like Wednesday or Thursday. And with that, adios. We are finished.